Hi everybody. In this video we're going to talk about unsupervised classification in ArcGIS Pro. If you're new to classification, you might want to check out some of our previous videos that go over the theory and a previous video on supervised classification. The big difference between unsupervised and supervised classification is that unsupervised does not use any training data. So we don't give it any examples of the user classes that we're trying to discriminate. So we don't tell it, here's what grass looks like, or here's what water looks like. Instead, we just feed it the entire multi-band raster and let it use an algorithm to divide the pixels into the groups that are most spectrally distinct. So let's go ahead to our GIS project. Here it is. We've been working on classifying a multi-band raster image of Crown Point State Historic Site in New York. And our ultimate goal is to break out classes for water, wetland, mature forest, scrub brush, grass, rock, which you can actually see some bare rock exposed here, as well as roads and parking lots. So I think we have 7 user classes that we're trying to break out. And here we're going to try to do that using unsupervised. So what are we putting into this classifier? We have 2 options at our disposal. One is a stacked multi-band raster that consists of 4 band ratio images derived from a WorldView 2 multispectral image at 2-meter resolution. There's the 4 band ratios. Then we have also stacked in there an NDVI, an NDWI, and the last thing is a canopy height that's been averaged and normalized. And that's going to help discriminate trees from scrub brush, from grass. Then we took that layer and we actually did principal component analysis on it. And we ended up with 7 principal components, which are now stacked in this raster and displayed here. So I think today we're going to actually feed this principal component raster into the classifier. So all classification in ArcPro begins in the Imagery tab. Then I've been using the Classification Wizard, which walks you through the process pretty conveniently. Brings up this GUI over here, and first we're going to choose unsupervised as the method. Then we're going to choose pixel-based classification. So this is going to consider all the pixels independently, and it's not going to include any information about how they're grouped spatially in the actual image. Now schema is important. Basically, this is where you're telling ArcGIS Pro what your classes are going to be. What are the user classes going to be? And obviously in an unsupervised method, we don't have to, it's not going to use this information as part of the classification process, but we do need to still specify a schema. It's going to use it on the back end as we try to assign our spectral classes into user classes. So there's a couple options here. One is that you can use the default schema, which is from the National Land Cover Database. That's a good place to start if you're just messing around. You can also generate it from training samples. And so in our case, we have a shapefile that actually has our schema in it that we made in the supervised video. So if you want to learn how to make a schema from a shapefile, you can go back to that supervised video. And in that supervised video, we actually created our own schema files. So most likely, if you've done that video, you have a schema already ready to go. So I'm going to try to just go find that. I'm going to look in my Crown Point folder here and possibly in my output folder. Don't see it in there. Maybe it's in this highest level. Here it is. So yeah, we've created a bunch of them messing around. So these schema files have a .ecs extension. So I'm going to just hit OK. And hopefully that's going to load that up with the same user classes we've been using before. Output location, for the moment, I'm going to leave this at the geodatabase default, although we have been having trouble writing to a geodatabase over our network. But let's leave it there, and hopefully it'll work. And we can leave reference blank for the time being. So we advance to the next step. Right now it's only offering us one method, which is ISO cluster. This is very similar to the ISO data algorithm we had covered in class. Essentially what's going to happen, it's going to take all of the pixel values, it's going to plot them up in a 7-dimensional kind of Euclidean space, and it's going to then seed that space with some randomly or maybe not randomly selected class means. And then it's going to start iterating, grouping the nearest pixels into that class mean, basically using a minimum distance or a maximum likelihood. It's going to group them into those means by nearest distance. It's going to reclassify the image and then keep repeating that process, merging classes as needed or splitting classes as needed. So the only thing we're going to specify here is the maximum number of classes. I'm going to be a little bit aggressive. Why don't we go with 12 spectral classes? 20 iterations seems to be reasonable. Max number of cluster merges is reasonable. I think this is possibly an important variable here, the maximum merge distance. Basically, you may need to adjust this if your images are not well scaled, for example. And minimum samples per cluster, in our case, I'll probably change this to like, 500 or something. Maybe we'll change it to 100. So this is how many pixels, the minimum number of pixels that a cluster can have. So raising this number prevents you from having just very small kind of isolated classes that don't have many pixels. Maybe I'll even make this 150. What the heck? Okay, here we go. So we'll try to run this. It's going to now essentially kind of train the classifier and come up with a preview image that we can take a look at and see if we're happy with it before we go on and generate the final classified image. This may take a bit, so I'll pause. Actually, here it comes. Came right up. So this is the preview of the classified image. Interestingly, it only came up with 7 classes. I'm not totally happy with that. I'd like it to come up with more classes. I'm going to repeat that process going back to maybe 50 samples per cluster and try that again. Okay, so that worked fairly well. We now have 11 classes, or I guess 12, which seems reasonable. And I think it had to do with this samples per cluster. I don't think actually here samples per cluster actually means pixels per cluster. It may mean actually pixels divided by 10, divided by the skip factor. Anyway, obviously we're quite sensitive to this variable. Okay, so moving forward, let's take a look at our spectral classes. Just what we know for sure, we can see that some of this dark brown is mature forest. We can see that the pink and the yellow are different flavors of water. We can see the kind of maroon is basically wetland, so on and so forth. This light green is grass, dark green is also grass. Looks like kind of this pinkish color is road. So we see that these spectral classes already, we can see that they do have meaning in terms of user class, but we're going to need to now recombine them and assign them into the relevant user classes. So let's go to our next step. In this step, it just wants to basically run the final classification. So I'm going to call this Unsup ISO 12 class. And I'm going to leave it without a file extension for the moment. And this will take a minute. I'll pause. Okay, so that unfortunately failed. I suspect it's because of either a file naming convention or a network issue. I'm going to try this one more time using basically the same file name but putting a .tiff extension on the end of it, and we'll hit run again and see if it works. Okay, so that second attempt with the .tiff extension did actually work. I'm now going to remove the preview. So what we're learning is it pays to kind of try with or without the .tiff extension. Also recall that these files are being stored actually in a geodatabase in our folder. So it's possible that if we run into more trouble, you may need to go back and repeat this process without putting them in a geodatabase. But let's keep going for the moment and see if our luck holds. So the next step is going to be to essentially assign each class, each spectral class into a user class. And I'll show you how this works. So here's our schema where we have our 7 user classes. And then here's our 12 spectral classes. So the spectral classes are going to be called the old class, and the user classes are going to be called the new class. And this is so awesome. We just click on water here. Notice this button comes to life. We click this button, and then we go into the image and click on the spectral classes that make up water. So in this case, I'm going to click on the hot pink, and that turns white now, and it gets tells us that it's now been assigned to water. All right, I'm also going to click on the green. Okay, that's now also assigned to water. Looks like we also have some of this kind of other green color, so I'll click on that, and that's now assigned to water. So we can now see all the water areas, for the most part, have been assigned. We do have this remaining purple color, and I'm going to click on that and try to assign that to water. I'm also going to actually now turn back on our base image so we can actually start to see what's underneath. So yeah, I think this purplish color should be assigned to water, so I'll click it. It's been assigned to water. Looks like we didn't lose. There's a couple places where we kind of lost it over land, but I think that is a fair sacrifice. Notice some of those places were actually in the shadows of trees. It's kind of crazy, but if you look, for example, right in here, the shadows of the trees actually had been assigned to that spectral class number 1. So I'm going to tolerate for the moment that ambiguity. I can see that spectral class was split across 2 user classes. Some of it was on water, some of it was on shadowed grass. But for the moment, we're going to put them all into water. All right, what else can we assign here? I can see this dark purple belongs in forest, so I'll highlight forest and click on that. And I think you're getting the idea, so I'm going to pause and do the rest of these assignments. You should finish your assignments, and then we'll keep going. Okay, so I've reassigned most of my spectral classes, and I paused on this last one, which was Spectral Class 7. It's shown in purple. And the reason I paused is because we've got an issue. This largely represents rock, so you can see that it's flagging out some of the rocky areas inside of our courtyard. It's also flagging out some of these rocks along the shoreline of the lake. However, it is also representing a lot of our roads. You can see a lot of these roads are turning out also as Spectral Class 7. It makes sense because roads are made from rock in general. But we've got a bit of an issue because it looks like we can only assign Class 7 into one of the groups, at least as far as I can tell right now. So I'm going to initially assign it into the rock group. I'm going to click on it. I think I can only assign that spectral class into one user class. So right now we're going forward without a road class. So we'll hit next. And this is going to take us into an editing screen where we can actually manually edit the image. We did do this in the supervised video. If you want to learn about it, you can go back to that. In general, I don't recommend manually editing your classified images. So in this case, we're just going to actually skip this screen, and our final classified data set here, we're going to give this a name. Let's call it Unsup ISO 12 class final. Try it with a .tiff extension, and then we'll hit run, and hopefully this is just going to export this final raster layer. Okay, so that finished successfully. We can now hit finish, and we are done with that classification workflow. Notice that our final classified image came out over here. All the classes are assigned to white. So I'm going to fix that by right-clicking on going to symbology. Then this is going to come up over here, and we are going to symbolize this using unique values. Class name is a good value. The one thing we're going to change is the color scheme. Instead of everything being white, for some reason, we'll change it to the color scheme of our choice. And that should now assign our user classes to a different color. Keep in mind, if you want to update them at all, you can, and if you want to update the way that they're labeled, you can actually just change that label directly in this column. So for example, our rock is actually rock and road. So you might want to just make that note to yourself. All right, and so then there's our final image. It's all as a last act. Keep in mind this went to a geodatabase because that's the directory that we were working in during classification. We're struggling with those, so as a safety measure, you may want to right-click, data, export the raster into a regular folder where you can find it more easily. Thanks, everybody.